Okay, these notes are ionic equations. Okay, an ionic compound will break up or dissociate into its ions when dissolved in water. So the moment you stick salt in water, it dissolves. You don't see it anymore. It's not a compound anymore. It's actually ions floating around. So let me move this up a little bit. Let's look at NaCl. Now, sodium chloride is made up of sodium ions and chloride ions that come together to form a sodium chloride crystal. When you put it in water, it basically dissociates, okay? So it's no longer sodium chloride. It's sodium ions and chloride ions floating around. So we would write it as sodium, and sodium has a +1 charge. With the elements, you have to look at the periodic table and see what, unless you, of course, memorize the charges, which I don't think most of you have. Okay, so we got sodium and then chlorine, or chloride. Okay? So sodium and chloride ions are the ones that are floating around. Okay, let's look at the next one, at bromic acid, or hydrobromic acid. Hydrobromic acid is made up of hydrogen ions, so you got your H and then your Br, and your bromine, or bromide ions. Okay, and they all have -1 charges and +1 charges. Let's look at the next one, MgI2. Okay, we also have to take into account how many of them. So there's one magnesium ion, and then this subscript here tells me that there's 2 iodines. Come on, there we go. Iodine has a -1 charge. So we have to take into account how many of each ion, not just what they are and their charge, but how many. So magnesium iodide breaks up into 1 magnesium and 2 iodines. Now, you can look on the periodic table for elements, but there's also ions that are polyatomic ions. So you'll have to look at your sheet. So if we look at the next one, here we have magnesium, which there is 1 of. And then there's 3 of the NO3s. So we're going to put the big 3 in front, NO3. Now NO3 stays together. NO3 is nitrate. It has a -1 charge. So we break it up like that. Now on the next example, we have 2 irons, so we're going to put 2 Fe. Now if you look on the periodic table, it's a transition element. How do we find the charge? Well, just like we did in Unit 5 when we were naming, we had to figure out the charge on the iron. Okay, so it's hooked with a polyatomic ion, and remember, if there's parentheses, it's always the number. Outside the parentheses, that's the charge on the iron. So in this case, there's a 3 outside the parentheses. So that means this has a +3 charge. Now your SO4, there's 3 of those. So there's going to be a 3 SO4, and SO4 has a -2 charge. Okay? This kind of is a little difficult, but you've got to be able to do it. When we get into complete ionic equations, you're breaking everything up into its ions. So you've got to be able to break these things up. Okay, let's go on to the next thing. Okay, so when we dissolve an ionic compound and then pour it into another dissolved ionic compound, the ions rearrange. So we've got 4 ions floating around, and if 2 ions, when they meet each other, are insoluble in water, they actually precipitate out. They fall to the bottom if it's a solid. If it's a gas, they bubble their way out. And if it's water, because water is really the only liquid that's going to precipitate, then it's going to join the water that's in there. Okay? So the resulting compound really is the only viable product. The other ones, well, we can indicate exactly what is reacting and what is not participating in the reaction by writing a complete ionic equation. So in other words, 2 ions are actually reacting. The other 2 are just kind of floating around there going, oh, cool, that's fun. Hope you guys have fun. We're sitting here floating around. They don't do anything. Okay, they're kind of spectating. They're watching. They're the spectator ions. So, but we need to figure out exactly what is going on in this reaction so we can write a complete ionic equation. Basically, we're taking all of these compounds that we've dissolved in water, and we're writing down what's happening. So as we dissolve them in water, they become ions. So we write the ionic equation, which shows all of the ions participating, and then it'll show the two that come together to form that solid or gas precipitate or liquid precipitate. Okay, so for example, a solution of ammonium chloride is placed in a solution of ammonium fluoride. Now, first we got to write the balanced double replacement reaction, because we need to know if the reaction happens. If the two products are both aqueous, that means nothing happened, and we're not going to bother with the ionic equation. But if there's a solid product or a gas product or a liquid product, yeah, then we're going to write it out, because then there was actually a reaction, and we can write out what happened. But first I'm going to list the ions. So we've got aluminum, +3. We got chlorine, or chloride, -1. Ammonium, and fluoride. Okay, so let's write the equation. So we've got aluminum chloride. Now remember, it's a solution of, so we know it's aqueous to begin with. And ammonium fluoride. Now, what's going to happen is aluminum and fluorine are going to change spots. So we're going to have aluminum fluoride, and when we look that up on our solubility table, oh look, it's a solid. So we know the aluminum fluoride actually precipitates out, so you would get a solid at the bottom. And then you'd have your ammonium fluoride, or chloride, sorry. And that's aqueous. Okay? So, yes, there is a precipitate, but let's first balance this, because we're going to need the balanced equation in order to do the complete ionic. So we have 3 here, 3 here, and we should be balanced. Cool. Now let's go on to the next step. Okay, now we can write the complete ionic equation. To do this, we break up everything into their ions, keeping it balanced as we go. Okay, so the first one we have is, we have AlCl3. So let's break that up. So that is Al plus 3, and we have to write the states of each thing next to it. And then we have this, there was 3 chloride ions. Okay, next we have, it's 3 NH4F. Well, that 3 means there's 3 of those compounds, okay? So that means there's going to be 3 NH4s and 3 of the fluoride ions. So basically, when you have your subscripts on an element or subscripts outside of a parentheses, they become coefficients. And the coefficients stay coefficients, but they just get distributed to both pieces or both ions of the compound. I know it's kind of confusing, but we'll do lots of practice with this. Okay. Now the next one is AlF3 solid. We don't break that up into ions because it precipitated out. That AlF3 is sitting at the bottom of the beaker, okay? It's not floating around in solution. So we don't write it as ions because it's not floating around as ions. It's not, the ions are not separated. They are together. It is a compound at the bottom. But the NH4 and the Cl, so I'll write it over here, 3 NH4 plus 3 Cl minus, these guys are still floating around, okay? So there's your complete ionic equation. It's got everything broken up. Now, since we're really only concerned about what 2 ions are really doing the reactant, we can write what's called a net ionic equation. Kind of think about it as your pay, okay? You have your gross pay, okay? So it's all the amount of money you made with your hourly wage, and then they take out all the taxes and everything. And then you have your net pay. Your net pay is what actually goes into your bank account. Well, it's kind of the same thing here. The net ionic equation is actually what's happening. What is doing the reacting? So we look to see the precipitate. The precipitate is aluminum fluoride. And to make up that precipitate, what happened was, whoops, aluminum, so the aluminum ion reacted with 3 of the fluoride ions floating around to form AlF3, solid. So that's the net ionic equation. That's all that happened. Okay, now we also have what's called spectator ions, and we'll get to that in the next slide. Okay, now there's two ions that didn't participate in the reaction, and those are called spectator ions. They're the ones that are quote-unquote spectators. Not really, because they don't have eyes, but you know what I'm saying. They're not participating. They're just kind of floating around. They're there to waste space, I guess. Or they're there because they were with the other compounds. So we tend to list them separately. So, but we don't have to put how many. So we don't care that there was 3 of them. We just say the spectator ions are NH4. You don't even have to put the aqueous. Just write them down. So NH4 and Cl minus. Those were the 2 spectator ions. Okay? So we'll try another example. Hopefully, after we've done enough of these, it'll become easy for you. Okay. So for this next example, write the complete ionic equation, net ionic equation, and list the spectator ions for a reaction where a solution of magnesium bromide is placed in a solution of lithium carbonate. Okay, so we've got magnesium. I like to list them ahead of time so I know what ions I'm dealing with to begin with, and that makes it a lot easier to write the complete ionic equation. So we've got magnesium, we've got bromide, we've got lithium, and we got carbonate. Okay, so those are all my 4 ions that are going to be participating in this reaction. So let's write the balanced double replacement reaction first. So it's magnesium bromide is reacting with lithium carbonate. Now, magnesium and carbonate are going to come together, and that is a solid, so we know the reaction works. So now we can write everything else. And lithium bromide is aqueous. Now we got to balance it out, so we need a 2 in front of there, and I think that's all we need. Yep. 2Br, lithium. Okay. So that's our balanced chemical equation. So at this point now we're going to write our complete ionic equation. So I'm going to move this up a little bit here. Okay, complete ionic equation. So I'm going to write CIE ... Okay, so I have my ions listed above, so it's going to make it easier for me to write my complete ionic equation because I know what the ions are already. So we have magnesium, and there's only 1. Okay, and then we've got 2 bromines. We've got 2 lithiums and 1 carbonate. So that's the whole left-hand side. Now the right-hand side, it's magnesium. Carbonate's a solid, so I don't break that up. Then I have 2 lithiums and 2 bromines, or bromides. And that is a minus sign. Okay, so there's my complete ionic equation. Now at this point, I really don't care about that. I want to know what exactly happened. You know, tell me what happened. So we're going to write our net ionic equation. So that would be, we're looking at just this. So it's going to be this piece and this piece. So it's going to be Mg plus 2 plus the CO3 minus 2. Whoops, you know what? I forgot to put the minus 2 up here. AQ gives you MgCO3 solid. Okay? So that's my net ionic equation. And my spectator ions, and I just like to write Si, are lithium and bromine. Well, bromide. There you go. That's it. So hopefully you guys get this. If you look at the practice problems, what you're going to do is take anything from 13 and 614 that worked, that had a solid or a liquid or a gas precipitate, and you're going to write the complete ionic equation, the net ionic equation, and lists the spectator ions in that. There are a couple equations that didn't work, that were no reaction. You don't have to worry about those. Okay, so just the ones that worked. Okay, well, I guess I will see you tomorrow. Bye.